So welcome students. So today we are going to see that Unit 4 that the topic is HDLC. So HDLC that the abbreviation is High Level Data Link Control. So data link control means it can be passed the information with the help of frame to the network layer. So the high level data link layer in the sense this is one of the bit approach method. Okay, so that can be connect with the synchronize with the data link method. And then the high level data link control that can be applied for the different set of rules with the help of the protocol that can be sent to the each and every data in the network function. Okay, so this is the main usage for the HDLC. So HDLC that can be support the ISO method also. It can be using the two kind of the connection function. So the first one is point to point, the next one is multi-point data link method. Okay, and it can be support the full duplex communication also. The center it can be send the information, at the same time receiver also that can be send the replay function. So this is the part of the statement. And next one, the HDLC that can be support for the some similar set of the protocol like the synchronized data link control. So this is one of the system for communicating the data, and then that can be applied for the another protocol that is a ADCCP, that is a data communication with the support of the procedures. And next one is LabB, like that is a link access process. So these also the similar protocol that these kind of the protocol that can be support for the while communicating the process in the HDLC. The next one is these also the features for the HDLC. So the first one is reliable protocol. It can be apply the go back function and then selective repeat function, etc. And full duplex function that can be sender and receiver send the information at the same time. The next one is bit oriented protocol. It can be applied for the bit shuffling process also, and flow control that can be accessing like the window size based information also. So these also the important feature that can be applied for the HDLC method. The next one is the HDLC. It can be applied the three kind of the function. So the first one is stations. That is just what are the station that can be applied in the sense primary, secondary, combined, and then the three data transfer mode also that can be using. So what are the three data transfer mode in the sense that is a normal response mode, that the thing is N or M, and then the asynchronous response mode that the short form is A or M, and then asynchronous balance mode, that is the short form is ABM. Okay, and the next one is there are it can be focusing like the three kind of the frames also, that is a unnumbered information supervisory system. So these also the important terms which we are going to see in the HDLC. So the first one is station. So station in the sense there are the three kind of the station was there. Okay, so the first one is the primary station. Primary station in the sense like the center that can be send the information with the help of the command line only. That is a command frame only. Okay. The next one is the secondary station. Secondary station in the sense that can be replay the information. How that can be replay in the sense response. Response as a term that can be replay the information. Combined station in the sense the both things that can be act in the system. Okay, so the primary and then the second. Primary in the sense that can be apply the frame like the command, and then the secondary in the sense that can be apply into the response. The both things it can be applied for the combined station. So these also the three station which we are going to apply to the HDLC method. So this is the sample structure for the thing. So HDLC basically it can be focusing like the unbalanced and then balanced information also. Unbalanced in the things what now, the primary station it can be send the frame look like as a command thing, and then the secondary station it can be response to the response to the primary station in the all time. Okay, so that it can be like the unbalanced mode, because the secondary station it can be send the responses mode in the same time, so that it can be occur like the unbalanced mode. The next one is like the balanced mode in the thing. So combined, that is a primary station or secondary station, it can be send the information like the command or response. Okay, so that can be passed to the primary station like that as a any one it will take and then send the information. The secondary station it will be respond or command to the at a time. Okay, so that it look like as a balanced mode. That is a two kind of the mode that can be applied to the HDLC in the stations. So we are going to see the briefly. So first one, that is a NRM. NRM in the sense what now? That is one of the normal response mode, and then APM in the sense asynchronous balance mode. Okay. So the first one, NRM. This is one of the unbalanced mode because we will see the thing. Okay. So first one, this is one of the point-to-point communication. This is one of the multi-point communication in the NRM method. Okay. So primary it can be send the frame like the command, and then the response that is a secondary part that can be send the command to that is a frame to the response. This is one of the point-to-point connection. Even we are going to access like the multi-point information, so we can take the primary that can be sent to the command. Okay, we have the different kind of the secondary station. So see, these kind of the secondary station, it can be send the information that is send the command to that response, okay, at a time, so that it can be look like as a unbalanced mode. Okay, this is called the normal response of mode. The next one is ABM, that is a asynchronous balance mode. This is one of the balanced mode in the point-to-point communication. How that can be occur in the sense, so we can use the combined in the sense both are say primary and secondary process also. These also the both are primary and secondary. So it can be accessing like that the command or response in the selective thing. So it can be pass the information to the next station. Okay, this station it can be send like the command or response in at a time, so that it look like as a balanced mode. Okay, so basically the NRM as a unbalanced mode, and then ABM as a balanced mode, like that. So this is the frame structure for the unbalanced and then balanced mode. So the next one is three modes for the data transfer operation. So each and every data which we are going to take like three kind of the operation which passing the information. So the first one is the NRM. NRM, this is one of the the unbalanced mode of the information. The response mode, it can be respond to the secondary station part. It can be respond to the primary station. Okay, and then the balanced mode, it could be the combined station mode, look like this one. Okay, that is a balanced one. So these also the three kind of the data transfer operations. The next one is non-operational mode. Non-operational mode in the sense that is a disconnection process. Okay, so connection we don't want means we just disconnect the process. That is a normal disconnection, and then the asynchronous disconnection mode. This is one of the non-operation that can be performed while the communication part. So the next one is we are going to see that the frame format structure, and then the control filter format structure. So basically the each and every frame, how that can be worked in the sense, so we can allocate the some of the frame of the size also. Okay, so this is the structure for the frame. So first we can allocate the flag. It's going to handling like the 8 bits. Address it's going to handling the 8 bit, and then the control it's going to handling 8 or 16 bit. That is the extensible function. These also the extensible function. Okay, and then the next one is the information, that is a variable, and then the FCS, that is a frequency checksum. Okay, it's going to allocate like that 16 to 32, and then the finally that can be wind up with the flag information. Okay, so this is the frame structure which we are going to handle it. Okay, so totally we have the three kind of the frames. The first one is the information, and then the supervisory, and then unnumbered. So we can call like that ISU. Okay, so basically the three kind of the frame, the information frame, it's going to handling the data like the user data, and then supervisory frame is going to handling the data like the control frame. Okay, control information, and then the unnumbered information, it's going to handling like the system memory function. So these also the information which we are going to handle in the each and every frame. So these also the allocated space for the control frame. So this is the frame structure, already we know. Okay, so now we are going to see that each and every frame of the function. So the first one is flag. Flag in the sense it's going to represent the 8 bit of the information. Okay, so first and then last bit it will be allocating like the 0, and then remaining all are 1. The next one is address. Address in the sense it will be taking like that primary station and then secondary station. Primary in the sense that is a to, and then secondary in the sense that is a frame. Sorry, from. Okay, so this is the address structure for which we are going to allocate the statement. The next one is control field. Control field means it's going to control the flow and then error control, and then the information field means it's going to take like the user information and then the management information, like that the I frame and then the U frame. The next one is the FCS, that is a frame check sequences. It's going to control the error detection part. It will be taking like the 2 or 4 byte of the information. So this is the frame structure which we are going to already discuss in the detailed manner. Okay, so this is the frame structure for the each and everything. The next one we are going to see that the control field format. Okay, so these things we can see with the very elaborately. Okay, so the first one I frame. This is one of the frame control field of frame. Okay, the first one is I frame. The next one is S frame. So I frame, this is the frame structure. It will be taking like the first bit as a 0. Okay, next 3 bit it will be allocating n of s. The next one is p bar f. The next last three frames is that will be allocating n of r. Okay, so first bit always the I frame it will be taking like that 0 only, and the next 3 bits it will be taking n of s. N of s in the sense what na center, that is a sequence number. What are the sequence number na? It will be taking like the 3 bit of sequence number like 000 up to 111. Okay, the next one is NR. NR in the sense what na? It will be taking like that the acknowledgement. Okay, center acknowledgement part, receiver acknowledgement part. Okay, so this is the center, this is the receiver acknowledgement part. In between of P bar F. The P means pole, F means final. So P in the sense what na? The bit it can be taking like 1 in the sense it will be passed like the primary to secondary. Maybe the bit it will be taking 0 in the sense it will be replaying message. Okay, that is a primary to center part. Okay, secondary part. So this is the information it will be taking. Like the bit 1 means it will be taking like the pole, that is a P. Okay, that the bit is primary to secondary. For example, bit equal to 0 in the sense it will be taking like the final F. So it look like as a primary to secondary information. So this is the part it will be taking like the I frame. The next one is S frame. S frame in the sense this is the frame structure for that. It will be taking the first two frames like the 1 and then 0. This is one of the fixed thing, and then next two as a code, and then next one is PF, that is a pole, and then final. The last 3 frames is like NR, that is a receiver, that is a receiver of acknowledgement nodes. Okay, so this is the first, and then this is the last, and then the 5th bit as a pole, and then final. The 3rd and 4th it will be taking the code generation process. Okay, so for example 0 0 0 0 in the sense like the receive ready, 1 0 in the sense like receive not ready, and then 0 1 in the sense rejection part, and then 1 1 in the sense selective rejection part. So these also the code information it will be taking like that 3rd and then 4th frame of the structure. Okay, so these also the S frame of that is a code information 0 0 1 0 0 1 1 1. Okay, the next one is like the U frame. So U frame, this is the frame structure for the U frame. So first 2 bit as a 1 1, that is a first frame as it will be taking 1 1. The next one is code, and then next one is PF. The last 3 as a receiver of acknowledgement part. Okay, the code it can be represent the different kind of the thing like what na, the code as well as NR, that is a receiver part. Okay, so the code it will be taking 0 0 1 1 1 1. These also the code ranges of the value. These also the NR ranges of the value. Okay, so each and every digit it will be representing the one of operation. Okay, so for example 0 0 0 0 1 in the sense normal response mode, and then 0 1 1 in the sense normal response mode of the extended, and then the asynchronous balance mode of the extended, and then unnumbered information, unnumbered acknowledgement, disconnection process. So these also the code information which we are going to focus on the U frame. So the next one is frame extender. So if you want, we want to just extend the frame, in the sense we just extend the frame into the particular frame of the information. For example, NS means we need to we want the extended, means we just extended the bit of information also. Okay, so this is the extended structure which we are going to use in the frame structure. We want means we just extended the structure, that is extended the bit of the information. So these also the three things of the frame. Now we just discussed like the unnumbered information supervisory. Basically the unnumbered, in the sense this is it will be taking like the disconnection part also. Information frame, in the sense it will be carry out like the acknowledgement. Actual information it will be passing to the acknowledgement information, and then the supervisory frame it will be control the flow and then error information also. These also the important frame which we are going to focus in the HDLC. Already we have discussed. So this is unnumbered frame. It will be taking the more advantages, or in the thing is like it will be supporting the mode setting commands also, and then recovery commands also. This is the more set of advantages which belong to the unnumbered frames. So this is the sample question for that, which this is under the U frame. Okay, so first we are going to connect with the asynchronous balance mode, and then after we just pass with that unnumbered acknowledgement, and then the next one is disconnection part, and then unnumbered acknowledgement. So this is the connection establishment. This is one of the connection release part. Okay, so whenever they are asking the thing, so first we can draw with the sum of the structure. Okay, what the frame they are asking, that the depends of the structure we want to make it. Okay, now we are going to see that U frame. So this is the node A, this is the node B. So this is one of the U frames. Okay, U frame structure. So flag B, like that. Okay, so in the between P and F, that is a pole and then final, it will be taking like that. What are the things they are asking, that the code it will be changing, that is a code that will be changing. No, so for example, look like this is the frame structure. Okay, so this frame structure will be taking the two part, that is a third bit and then fourth bit, that it will be changing the code information what they are asking. Okay, that the code it will be put. For example, this is the information for that. So they are asking that asynchronous balance mode. Asynchronous balance mode, that the code value is what now, 11 and then 100. It will be sent to the node A to node B. And then the unbalanced acknowledgement, that is a replay part, it will be what the code, in the sense we have to refer the code information. So unnumbered acknowledgement part 001100. Now we are going to put into the code representation frame. Okay, that is a replay part. This is one of the node A, node B data transfer which connect to the connection establishment. Next one we are going to see that the connection release. Connection release at the thing we can take with that disconnect part. So it will be changing the code also. Disconnection means what now, 00010. So we can refer with the code frame. Okay, so connection parts it will be taking, that is a disconnection part 00010, that is a disconnection part. And then we can apply, this is one of the node A to node B, that is a connection release the part. And then after we can send to the acknowledgement, that is a unnumbered acknowledgement, that the code is 00110 as a same. Okay, it will be replay for the node B. So this is the frame structure which will belongs to the U frame. Okay, so first the U frame they are asking like that asynchronous balance mode, that is one of the connection establishment process. The next one is connection release process. So this is the detailed information for the HDLC. Okay, so thank you students.